Sugar is one of life's greatest indulgences. You can add it to coffee or tea to achieve that perfect blend, or to food products like chocolate or pastries to achieve that perfect taste. But have you ever wondered how sugar is made? Sugar, also known as sucrose, is a disaccharide composed of glucose and fructose. This simple carbohydrate has 12 carbon, 22 hydrogen, and 11 oxygen atoms. It serves as our body's source of energy to carry out various brain and bodily functions such as muscle contraction and temperature regulation. Sugar is produced naturally in all plants through the process of photosynthesis. However, not all plants contain the same amount of it. In fact, it occurs at concentrations high enough for recovery only in sugar cane and sugar beets. These two have the greatest quantities of sugar. Hence, they are good choices to be its sources. To put sugar production into context, let's see some statistics. According to the Sugar Regulatory Administration, the Philippines' sugarcane industry contributes to no less than 70 billion to our economy annually. Sugarcane is planted to about 422,000 hectares out of a total land area of 30 million hectares. The sugar industry has become the source of livelihood of about 62,000 farmers. Going back to our question, how exactly is sugar made? The production of sugar from sugarcane is twofold. First, the extraction of raw sugar, and second, refinement of raw sugar. Each distinct operation consists of a series of processes which separates sugar from undesirable amounts of polysaccharides, lignine, proteins, and other impurities. Here is a quick overview of the sugar production process. First, the sugar cane is shredded and sent to crushing mills which extracts the juice containing the sugar. Next, the juice gets clarified and the impurities are removed. It then enters a series of evaporators which removes the water. Afterwards, crystals are formed from the thick syrup, which then enters the centrifugal stage where they are washed and collected. Then, the raw sugar is dried and sent to the refinery for processing. We can now dwell into the intricacies of the extraction process. The first step is preparation. The production of sugar starts with the preparation of the freshly harvested sugar cane. The canes, which may be harvested by hand or by machine, are unloaded mechanically and washed extensively in rotating drums to remove dirt, rocks, and other foreign matters. Subsequently, they are shredded into smaller pieces to prepare them for extraction. Moving on, to extract the sugar juices, conventional milling or diffusion may be used. In milling, the stalks are crushed and compressed between the heavy and grooved metal rollers to separate the juice from the fibers called bagasse. Water may be sprayed during this process to improve extraction. Sugarcane extraction is often done through milling machines. On the other hand, in diffusion, a continuous and countercurrent water stream is used to extract the juices. Unlike sugar canes, wherein the juice is extracted by means of crushing and grinding mills, sugar beets are processed in an extraction tower by means of leaching with hot water. Specifically, sugar beets are cut into thin, wedge-shaped slices called cosettes prior to leaching so that the distance required for the water solvent to diffuse into the biological material is reduced. Once the beets are sliced into cosettes, they are soaked in hot water to allow the cell membrane to open, clearing the way for the sucrose to exit towards the next operation, wherein the cosettes are pumped in the bottom of an extraction tower. A shaft then transports them slowly upward against the downward flow of hot water, which draws out sucrose, producing the raw juice.
Since the juice is acidic and turbid, a clarification stage is needed. Clarification is a process designed to remove both soluble and insoluble impurities which were not removed by preliminary screening. The process employs lime and heat as the clarifying agents. Milk of lime neutralizes the natural acidity of the juice, forming insoluble lime salts. The salts collect a lot of the non-sugars, therefore by filtering out the chalk, impurities are also taken out. Once the juice is clarified, the sugar liquor is ready for sugar production, except that it is quite dilute. To concentrate this clarified juice, water is removed through a series of evaporators. Each subsequent evaporator has higher vacuum pressure than the previous one. This setup allows the sugar juice to boil at lower temperatures. In this process, inorganic salts such as silicates and oxalates are removed and a syrup with a 50 to 65% concentration is obtained. Note that multi-stage evaporation is used to utilize steam efficiently and to create a low-grade steam that can be used to drive the crystallization process. After entering a series of evaporators, the syrup is sent to a single-stage vacuum pan where it is evaporated until it reaches supersaturation. Small sugar crystals are added afterwards to initiate the crystallization process. These crystals were added to serve as the nuclei for the formation of the new sugar crystals from the syrup. This dense mixture, called masquit, is discharged into a crystallizer to maximize its removal from the syrup and to continue the process. Once the crystals reach the required size, the masquit is transferred into high-speed centrifugal machines. Rotating at 1000 to 2800 revolutions per minute, the centrifuge allows the separation of the raw sugar crystals from the molasses. The crystals remain in the inner centrifugal basket while the molasses is centrifuged to the outer shell. The centrifuge molasses undergoes crystallization and centrifugation again to maximize the yield. Once the sugar is centrifuged, it is cut down and sent to a granulator for drying. The raw sugar obtained from this series of processes is not yet food grade. It must undergo a refinery process until it is safe for human consumption. The first refinery step is known as affination. In this process, raw sugar is washed with warm saturated syrup to soften or loosen its molasses coating. The resulting mixture is spun at high speeds in a centrifuge while hot water is sprayed to separate the crystals from the syrup. The washed raw sugar is melted to produce a sugar liquor whose concentration is around 68%. This liquor is passed through a screen to get rid of particulate matters. To remove inorganic components and the turbidity of the sugar liquor, it is purified and clarified. This process may employ either carbonatation or phosphatation methods. In carbonatation, lime is added and carbon dioxide is bubbled through the mixture. This allows the production of calcium carbonate precipitate, which acts as a filter aid that traps color impurities. In phosphatation, lime and phosphoric acid are added and air is bubbled through the mixture with a flocculant. The addition of lime and acid produces calcium phosphate, which is bound together by the flocculant to form a floc. The floc is separated from the liquor as it attaches itself to the air bubbles. Color impurities and small particulates are also removed in this process. The clarified sugar is filtered to produce a pale yellow liquor. To decolorize this, adsorbents such as granular activated carbon and bone char are used. In this process, soluble impurities are also removed. The decolorized sugar liquor undergoes the same evaporation and crystallization processes used in extracting the raw sugar. However, this time, these series of processes result in a refined sugar. The refined sugar still contains about 1% water by weight. Therefore, it is dried by a stream of warm, dry air in a granulator which operates at about 110 degrees Celsius. The dried refined sugar is sorted by size through vibrating screens and sent to conditioning and storage bins. Sugar is then sent to be packed in the familiar packaging we see in grocery stores, in bulk packaging, or in liquid form for industrial use. Sugar is indeed one of life's greatest indulgences. However, just like any food, remember to take sugar and sugar-based products in moderation.